I don't teach this one. This one we pause a little bit. We just explore to another idea where I try to import your friend's file with regard to the COVID-19. So I already download the file covid.slr.csv. So how you want to get this file? You just go and navigate into my GitHub, and then you will saw something to do with the covid.slr.csv. You can download this file. After you download this file, you can open it straight away. So how to open it? Just go to the file, import data. I'm going to use the function here as an import data, and then followed by the CSV data. And make sure that the data is quite correct lah in terms of their arrangement. I already see it before, therefore I can straight away download it. So go for the open, and automatically it will generate a preview data from the file. And after you're confident enough that it is being separated delimitation based on the comma, then you can proceed OK button, and then it's come out with the SPSS file straight away. After that, please make some adjustment with regard to these values. Example, the first one is the date. The date here, it seems like a string. Then you can change this one into a date format and indicate the type of variable date will be as follows. Iaitu day, month, and also year, followed by the OK button over there. And it's become a date function already. And then you've got the confirmed cases, temperature, humidity, wind speed, rainfall, sunshine, hours per day. So our friends here are already considering all the factors that are very useful to all of you, which is the naming process is already there. So maknanya nama variable tu dah ada siap-siap. So kalau tuan-tuan dan perempuan masih bermalas-malasan lagi, tak patutlah sebab kawan awak dah buatkan untuk kamu. This is the data for the COVID in October 2020. Is open data until 2021. So we just want to explore COVID October 2021. Okay, we just want to explore based on the 1 year data and also their relationship or perhaps their trend towards the meteorological condition. Okay, so far so good. You follow, Alright, so if we browse through, the first step is of course lah, you kena buat normality test. Lagi buat apa? You kena tengok sama ada extreme value ke tidak. You kena tengok sama ada is there any relationship or not. So by using the rule of thumb, the first rule of thumb is basically go for the bivariate analysis, where you are trying your best to find out is there any relationship with the confirmed COVID-19 cases. So in this case, I'm just going to run this thing inside my syntax. And remember, I open 2 files now because this one is become dataset 2. You can see over here is dataset 2. And if I see it inside my syntax, I already have a look about this. You see, we got dataset 0 and dataset 2. So make sure that you select appropriately when you want to run your syntax. So in this case, data activate set as a dataset 2. So I run this one. So that means the computer know already that I will run everything in the dataset 2. So the dataset 0 or our previous example are going to be ignored at this moment. And then we are going to run for the another one, which is the correlation. So I run this one. You see, why I did not like to put the longer name is because it's make my life much more not easier in terms of reanalyzing it. That's why kalau bagus, you buat S1 dengan Y lah. Tapi yang ini contoh kawan kita bagi ni pun penting juga. Otherwise nanti data tu hilang, dia punya label, kita tak tahu apa makna dia kan. So we can run, and after I click the Ctrl R, then the output are going to be generated for you. So let us see. Confirm COVID command correlation undefined variable or a scratch system was specific in a variable which is accept only a standard variable. Check the spelling. Okay, so I got some errors. So let us go back our data here and then just have a look. What is the problem with our data? Seems like no problem. Why it says that there is a problem? Boleh ke? Sekejap. Okay, let me run everything. Dapat run? Okay, I already run it. And then the most important part is actually looking for this one, confirm COVID-19 cases. So if you see, the confirmed COVID-19 cases is only correlated with the sunshine durations hourly per day. Yes, betul kita akan buat regression. But first of all, it is worth noted that we look first into the correlation. Why? If we find out that there is nothing to do with the correlation, possibly it will be higher also, nothing to do with the regression. So the best thing to do is look at this. For example, confirmed cases, COVID-19 and also sunshine. And then please have a look about the sunshine and also the other variable. Sunshine is correlated with the temperature. Sunshine is correlated with the humidity. Sunshine is correlated with the wind speed. So in a nutshell, I would say that most of these are only the factor that are going to be involved. Other than this, it will be not. Example, rainfall. Rainfall has nothing to do with the COVID. In my opinion, based on this data. Pardon? Date tak payah masuk. Yes, correct. Okay, I make a repetition. Just now, I go for analyze, correlate, and bivariate. And I insert everything except for date. And then after I click run, paste, and then highlight and run, I got this kind of output. Then based on this output, I will see, I have seen that the COVID-19 cases is only correlated negatively with the sunshine duration per hour daily. That's mean higher the cases, the sunshine is lower. Means that lagi kurang cerah, lagi banyak orang kena COVID. Betul. Sebab apa? Banyak orang duduk dalam rumah lah yang kena COVID tu. That is the theoretically right also lah, because those who are being infected with COVID are not allowed to go outside, kan? Alright, so that conclude the first one, which is theoretically correct, but the correlation is quite low at this point. More than 0.2 is considered low, but it is significantly correlated. However, we only seen this as the functions or as the factor that are correlated with our confirmed cases. So the temperature, humidity, wind speed, rainfall, and others may not be relevant. However, if you feel that you still want to explore it more, then it is good to note whether the other factor is correlated with the sunshine or not. Based on this, you look into the sunshine, you can see that the sunshine is correlated with the temperature, sunshine with the humidity, and sunshine with the wind speed. But nothing to do with the sunshine and also the rainfall. So that means the rainfall are going to be withdrawn from any analysis with regard to the regression analysis lah. Otherwise, if you try to do it and put it inside also, it will have no effect will be occurred. Okay? If you don't believe me, you can try lah. But usually, it will not happen. Okay, so that is the first primary concern and also approach when you talk about the analysis of data for regression analysis. Second, then we start to analyze it. So, teman-teman, let us go to explore the analysis by using the regression analysis lah. So, you can go for analyze, followed by the regression, followed by linear regression. And then you can insert your dependent variable will be confirmed COVID cases. And then followed by the temperature, followed by the humidity, followed by the wind speed, followed by the sunshine duration per hour. Do not insert the rainfall because the rainfall have nothing to do with all this. Okay, let me just go another one, which is the block 2. Okay, ini you tak buat you tak buat yang I buat. You just tengok je. The block 2 ni I masukkan semua. Just to give you an idea what will happen if I have 2 blocks, which is the one block is consists of this, and then another block will consist of all the other things, or the combination of it. And then I go for the statistics. I request for the descriptive and also collinearity diagnostic and confidence intervals. In fact, I also do not want to request all this. Okay, I just want to run it in a much more robust setup, just to give you an idea about the output. Okay, so I click the OK for now only for me. You all don't need to do that. Just to give you an idea about what happened if I run for these 2 models. So you can see there will be the sunshine duration, hours, wind speed, and humidity, and the rainfall is actually being removed. Nampak tak? All requested variable entered, which is the rainfall only, are going to be inserted inside the second model. So this is why dia ada first block dengan second block. Faham? So the first block and second block have the ability for you to see the adjustment of the R square based on the before you insert and also after you insert. Okay, nampak So is there any improvement? The improvement is not significant, ataupun the improvement is nothing to do with all this. That's why kalau you boleh disregard pun, you disregard je lah benda-benda tu. So it's also same with this. Rainfall also does not indicate some significant predictor. So that's why kalau kita buat dalam correlation pun tak significant predictor, dia tak payah masuk lah dalam model. Adakah dia membuang masa? Dia tak membuang masa pun. Tapi dia tak improve pun our model functions here. Sebab adjusted R2 is still none. Still does not give any good indicator. Yes, sama je. Okay. So let us go back, which is the normal idea about the analysis, regression and linear. So let me just repair a little bit here and there by just removing all this. So you know exactly why we use the apa tadi? Block. Block ni adalah contoh tuan-tuan dan puan, if you got something to do with the steps. You want to run for the block 1, which is this factor, and then followed by the another one. Okay, so example. Let's say the temperature and humidity is quite related to each other, and then the wind speed and also the sunshine are quite related to each other. Let's say this one is another cohort ataupun another spectrum of climatology, and then another one will be another climate condition. So you can also run that kind of situation to see whether these two components combined together as a group will be having a significant model fit or not. So you can see humidity and temperature, sunshine and also duration. You akan dapat something like this lah. So the first model is quite low, or we call it as does not make any sense at all. The first one, the humidity and temperature only. And then followed by the sunshine, where you try to adjust the requested variable, it become a significant model fit. So this is the idea lah, kan? Yang tadi ada kaitan apa dia? Sunshine. Kan? You punya Pearson. You punya Pearson correlation. What is the hypothesis? Sunshine, betul lah. So that's mean this is the good example to say to you that if you did not include the sunshine in your model, that's mean your model will be gone wrong already. No use at all if nothing to do with the sunshine. You must do something with the sunshine. Faham kan? Tengok kat situ kan? Nampak? Temperature humidity, nothing. Dia jadi macam ni. Yang ini sekali dengan sunshine, dia akan mulakan hidup dia sebagai sunshine. Dia akan meningkatkan kesyainshanan lah, macam tu. Alright, so ladies and gentlemen, let us go for the last one, which is we insert everything and then we analyze it using the linear regression. Okay, let me just improve a little bit here and there. Reset. You can put your confirm COVID followed by the sunshine as the independent factor, followed by the another one, which is we insert everything, but we disregard a few things, which is the dates and also the rainfall. Okay, what is the difference? Sunshine only and also sunshine with others. Okay, make sense? Make sense, kan? Sebab this another block is actually reflected with the whoever parameters that are correlated with the sunshine directly. Okay, and then followed by the in this case I'm going to click the paste lah, because I want to generate the regression. And then I'm going to highlight and click the Ctrl R. Remember, there are a few things that you must understand, a few output inside our analysis. The first one that you must understand is the model summary. So model summary is about the descriptive. So descriptive indicate that the R square is changed or not. The R square is changed from 0.07. If only one is 0.07. But if you see that the adjusted R square also will be like that, it is also some increment, but not very good lah increment. It is good value. It is not good value at all, because it's only zero. It is only 7%. It's only 7%. Sorry, 1, 2. If you times by 100, 0.07 is equivalent to 7%. So that means only 7% explain variable by wind speed, temperature and humidity, but the other things that explain the occurrence of the disease, that means 93% is not known. It is other factors. Yes. So you punya equation ni seems like quite not useful lah in terms of getting only these parameters. Yeah. Alright, and then you can see that ANOVA, the model 1 is fit, the model 2 also is fit. What is the difference? There is no difference, but both of it are fitting the models. That means the sunshine only is fitting the model. The sunshine with the other are also fitting the model. Cuma beza dia tadi kan, sunshine only is around 0. Ni lebih kurang 0.69 is also about 7% kan. Masukkan lagi 3 pun 7% juga. So that's mean improve, but a very little bit lah. Okay, and then we go for the coefficient. So the coefficient table, or the last table that I mentioned to you before, is the table that we use it for what? This one is for the predictor, significant predictor. So you can see there is a significant predictor for the sunshine. There is a significant predictor also for the sunshine, but not for others. Same like what we correlate before. Betul lah? So when we want to combine it with the other friends also, they still do not perform it well. That's mean what? That's mean only sunshine lah related to this case. That mean the sunshine can become one of the predictor that may predict something lah, but not very good lah. May predict 7% only mah. 7% or something lah. Something will happen lah with regard to the sunshine. So if I see the sun or no sun, so I know what happened to the COVID cases. Something like that. So how you want to interpret it? By looking into the beta. The beta that minus means that inverse to whatever happened that our cases. Contoh minus means that lagi tinggi case, lagi kurang sunshine. What does that mean? Lagi gelap lah. Lagi gelap, lagi kurang lah. So lagi menacur nak dekat kiamat, lagi kurang case lah. Ibarat gitu. Sebab tak ada matahari. Contoh lah. Based on this. So same also goes to the values. So you can see that the beta is around to 942. So 942 we do not know. What is it 942? But when we want to correlate and relate it with the other models, that's why we use the coefficient for the standard error, which is the beta, this one, standardized beta. You see, minus 0.26, you can compare the minus 0.26 with the temperature, with the humidity and the wind speed. The highest one will be the sunshine as compared to the others, which is lower. And then the others is actually a positive correlation, which is this one is the negative. But the others is not significant. This one is only the significant one with the predictors kita, iaitu COVID or not COVID, ataupun the numbers of the COVID cases lah. So this is a little bit here, a little bit good models to see that there is a significant predictor with regard to the sunshine exposure, but it is not relatively useful in predicting everything. It does make some sense, but carefully need to be determined by the other factors also lah, because it's only presented about 7% only of the variance explained of this case. Okay, ada beberapa soalan? Alright, ini baru satu contoh that you are going to run it in a much more simplified manner using only enter method. So as I mentioned to you before, you can also rerun the analysis based on the advanced condition, like the stepwise. So if you run in a different setup, which is using the stepwise and so on, you are going to see a different perspective in terms of analysis. So what I meant by that is the volume being entered or removed are going to be removed straight away if there is not a significant improve or it's nothing to do with that models. That is using a stepwise. Dia akan cut it short when there is nothing to the interest of the computerized punya computations. You can see model number 2 is no longer being accepted at all. That's why it's being discarded because it is not significant kan? Betul tak? In influencing the prediction model to be predicted the value of the number of cases. So same also kalau anda pergi kepada backward and also you nak go for the another advanced modeling technique lah, is either stepwise ataupun backward ataupun forward lah. Ini semua adalah look into the steps taken for the analysis. Okay, ada beberapa soalan nak untuk linear regression? I do believe that all of you should understand and really get lah whatever the story that I'm telling you just now.
Kenapa kita nak buat blog?
Blog. Kenapa buat blog? Sebenarnya untuk level awak pun tak payah belajar blog ni.
Ya, betul tak?
Sebenarnya level awak tak payah belajar blog. Blog ni is only being useful if you have a very good and strong foundation of the theoretical knowledge that you want to test. Contoh macam tadi, if I combine this function as a one group, contohlah kadang-kadang kan bila kita buat eksperimen atau kita ada data macam climatologist ni, what we are going to see whether there is some relationship with this variable with the other variables that are intact or related to each other kan. Contoh sunshine ni is of course lah related with the temperature, because higher sunshine, higher temperature lah, lower sunshine, lower temperature. Okay, something like that. So if you have a solid foundation of that, that's why you want to group it as a one function. Now you are no longer looking at the sunshine only, you look at a group of function, which is the sunshine related exposure, something like that lah, which is consists of temperature, sunshine, the other things lah. So that's why we use the block. If you have that theoretical knowledge. Contoh lain kenapa pakai block? The block is being used, contoh, you ada makanan, dan makanan itu terbagi pula pada vegetable, non-vegetable, karbohidrat, something like that lah. So, you want to group it as your theoretical knowledge. So that you know that the theoretical knowledge that you want to test is whether related or not related. So, same also goes to kita punya field ni, environmental health. This is climatology. You ada pula lagi data lain, contohnya human behavior. You ada traffic score ke whatsoever lah, whatever it is. So, itu adalah you punya a group of blocks. So, based on the group of blocks, you can identify which one is much more better in terms of making a prediction or which one is not better. That's why kalau you pakai stepwise, it will remove those model that are not good. That's why you letak dalam block, okay, model ni tak bagus, dia being kicked away by the system. Okay, that is the idea lah with regard to this thing. Okay, it's based on the regression analysis, which is we call it as the forecast. So to do forecast here, okay, yeah, if you can try to follow, analyze, non-forecast, you can go for the you can go for the create traditional model. When you want to do a traditional model, you got some error lah. Why? Because you need to define the date and time. So before you can do the definitions of the date and time, you need to define the case is what in terms of the date here. So to do that, you need to go for the transform, and then you need to do some sort of create a time series. Okay, ini kita kalau sempat kita belajar petang lah. Kalau tak sempat tak apa. Saya bagi you teaser je lah dulu, walaupun you tak akan ambil masa pun nak tengok. Sekejap lagi, you mesti nak pergi makan je. Okay, betul? Okay, so that's all yang saya nak cerita. Baik, apa yang kesimpulan dia saya nak cakap, semua data yang kamu dapat ni, kalau sempat lah, saya tunjukkan sekejap lagi, how the regression are going to help you in terms of making forecast. In a simplified manner, contoh kan, you have a 1 week data here, or 7 week, we are going to forecast what happened next week is because what happened tomorrow is actually what happened yesterday. What happened the next following 2 days is actually what happened today. Dia macam itulah. Apa yang berlaku esok adalah disebabkan apa yang berlaku semalam. Apa yang berlaku lusa adalah sebabkan apa yang berlaku besok. Macam itulah. Hypothesis. So we are going to arrange the data accordingly, and then we can also calculate and estimate it using the Microsoft Excel lah, ataupun kita boleh nak senang kita pakai SPSS. Okay, kita tangguh dulu kelas kita. Nanti kita